A very good afternoon to all of you. I'm interacting with a batch now out of 20, 14 are in front of me. Okay, so we are having enough strength to move ahead. Enough audience are there. Okay, first of all, very good afternoon. Before first midterm examination, we are done with three units of our syllabus. Our syllabus is Dmgt, discrete maths and graph theory. The syllabus is divided into two parts. We all know that. First three unit belongs to discrete maths, and last three units, that means unit number 4, 5, and 6, is 3 units belongs to graph theory. And graph theory, that portion we had already covered before first midterm examination. Okay, so we can say we are at 50% in our syllabus, and right now in our lecture session we are dealing with our first unit, which is the first unit of discrete maths. Is it? So if we talk about the graph theory, the portion related to graph theory, for unit number 4, 5, and 6, we are having 3 separate assignments. Is it? Assignment 4 for the graph entry, assignment 5 for matrix representation of graph, and as per I know, before first midterm examination, we guys are done with both that assignments, assignment 4 as well as assignment 5. We are done with that, is it? It will be good if one of you will confirm by unmuting yourself. Girish, am I Girish, unmute kar beta. Girish Purohit.
Yes, sir.
Okay. As per I know, हम फर्स्ट मिडसेम एग्जाम से पहले असाइनमेंट 4 और 5 दोनों कंप्लीट कर चुके हैं, ठीक है ना?
हाँ सर.
Good. So we are left with the 6th one, which is the last assignment from the graph theory portion. That assignment 6 is right here in front of your screen. In your screen, is it? The same assignment I had shared in our WhatsApp group. Even I had uploaded this assignment in Google Classroom of our class, and same assignment I have uploaded in our Marwari login, student login. Is it? So you may get from anywhere. लॉगिन में से चाहिए वहां से निकाल लो. व्हाट्सएप में भी मैंने आपको पर्सनली भेज दिया है सभी को, वहां से निकाल लो. एंड you may even access the same from the Google Classroom even. Okay, so this is the task of this particular lab, assignment number 6. Assignment 6 is, in this particular assignment, we are focusing on the planar and non-planar graph. We will be discussing the questions. First of all, let me give some of the common instruction to all of you. Already, all the students are member of our Google Classroom. Is it? One of the Google Classroom is there with the label 4TP1+4TO1. We all are the member of that. And some of you, I cannot say some of you, almost most of you have submitted assignment 4 over there. Most of you have submitted the assignment 4 in the Google Classroom. Now, earlier the deadline for the assignment 4 was before midterm examination 1. Now, I'm giving the extension for this 3 assignment 4, 5, and 6. All of you are supposed to upload your PDF, solution PDF for this 3 assignment 4, 5, and 6 up to 3rd of April. Is it? Today is 25th March. I'm giving you proper and enough time up to 3rd April. So 3rd April will be the, I'm going to consider that date as the last date for half of the term work of this particular semester. In that particular half of the term work, I need 3 assignments, assignment 4, 5, and 6. Is it? अब आप में से काफी सारे बच्चों ने 4, 5 अपलोड भी कर दिया है. We are good. अगर बाकी है, किसी का भी बाकी है, then I will request कि please 3rd April से पहले कर देना है. उसके बाद ये डेडलाइन एक्सटेंड नहीं होने वाली. This is the last chance. Okay? जिसका भी बाकी है उसके लिए. बाकी के सब लोग तो रेगुलरली सबमिट कर रहे हैं, तो कोई इशू नहीं है, इज इट? जैसे जैसे वो असाइनमेंट चेक हो जाएगा आपका, यू विल हैव योर ग्रेड ओवर देयर। आप वहाँ पे जाके आपका ग्रेड भी देख पाएंगे कि आउट ऑफ 10 मैंने आपको कितने मार्क्स दिए हुए, इज इट? ऑल द थिंग्स विल बी विजिबल ऑन द गूगल क्लासरूम। इन द लास्ट टैब, दैट ग्रेड वाली एक लास्ट वाली टैब आती है, वहाँ पे आप देख पाएंगे। Are we good? Is there any doubt related to that? Is there any doubt related to that? Then unmute yourself and
No,
let
sir.
me know.
No, sir.
Okay, तुषार, okay. सो मैं देख पा रहा हूँ, देखिए कितनों का बाकी है, मैं एक बार नाम ले लूँ। आदित्य जैन शायद बाकी है, अजहर डाबा, ये अजहर डाबा इज ऑलरेडी शायद, नो फाइल इज देयर, ओके। Most of the international students are left with that, and all the international students belongs to B batch. Arjun का बाकी है, अर्पित, अविनाश, आयुष, then after Benin, then after धार्मिक, दीपेन, फिर जय, जयदीप, जिग्नेश, कुणाल जोशी, महाराणा, मानव गांधी, मानव आपका भी बाकी है बेटा, असाइनमेंट 4 सबमिट करना भी बाकी है, मोहम्मद केफ का भी बाकी है, नैतिक जैन इज येट लेफ्ट विद दैट, ओम परीक, पेमा वांगड़ी, प्रांजुल इज नॉट देयर एनीमोर, प्रीत का भी बाकी है, प्रियांशु झा, शिवम तो आता ही नहीं अभी, तन्मय, तुषार सेठिया, यू आर ऑल्सो लेफ्ट, तुषार सिन्हा का हो चुका है, तुषार सेठिया इज लेफ्ट, Jane, then after Vashu, then after Vibhusha, Waldi, and yep, see Dana. इतने लोगों का अभी असाइनमेंट 4 भी सबमिट करना बाकी है, ठीक है? सो द डेडलाइन फॉर द असाइनमेंट 4, 5 एंड 6, अली असाइनमेंट 4 की डेडलाइन तो मिड सेम से पहले थी, उसको एक्सटेंड किया हुआ है अभी, सो दिस विल बी द लास्ट चांस, ओके? टेक केयर फॉर दैट। असाइनमेंट 4, 5 और 6 तीनों की सॉल्यूशन वाली पीडीएफ अपने राइटिंग में, बिकॉज गूगल क्लासरूम इज प्रोवाइडिंग मी दैट फैसिलिटी, आई कैन इजीली चेक द प्लेगरिज्म, आई कैन इजीली चेक द प्लेगरिज्म। वो मुझे नहीं करना है, वो सॉफ्टवेयर करके दे देगा मुझे, yes sir, there is a plagiarism in both this assignment or this 10 assignments, okay? So take care, it should be in your writing, okay? So okay, good. These were some of the common instruction which I was supposed to convey to the entire batch. Now, तो ऐसा तो नहीं ना इस बैच में जो कि गूगल क्लासरूम में मेंबर नहीं है? आई डोंट थिंक सो, पर अगर कोई है तो बता दो। इज देयर एनीवन हु इज नॉट इन देयर, who is not the member of Google Classroom? I don't think so. Okay. Okay, now let's stick with today's work. Let me go through some of the questions of assignment 6. This is assignment 6, which is there in your screen, and it focused with the planar and non-planar graph. Now, first, in the first question, okay, the most important definition that one must be clear about the planar graph, and we can say that a graph is a planar. If you can identify one of the embedding means you need to represent that particular graph in such a way that none of its two edges are going to intersect in the graphical presentation, is it? If you can identify such embedding, then that graph is known as a planar graph. And if we are dealing with a planar graph, then that we can easily identify the number of regions, exterior region, interior regions, is it? And based on the exterior and interior region, we are also having one of the formula that is known as a Euler's formula. अगर आपको याद हो तो I have already discussed that part in our lecture, and as well as the assignment, I had also shared that presentation of that PPT of Unit 6, वो भी मैंने भेजी हुई है in Google Classroom even, and even it is there in the Marwadi login, and even I had forwarded the same presentation in your WhatsApp also. So for the solution of assignment number 6, you may take help from that particular presentation. वही presentation है जहाँ से मैं आपको पढ़ा रहा था, ठीक है. So उसमें वो Euler वाली formula है. Once we are confirmed that one of the graph is planar graph, then that Euler formula is always true. So in the first question, we guys are supposed to check whether the following graphs are planar or not. If we talk about the first one, second and third दिख रहा है. Second and third are the planar graph because none of the edges are intersecting. None of the edges of second and third graph is intersecting each other. So yes, second and third graph तो planar graph है ही है. पर बस आपको देखना है फर्स्ट के लिए कि फर्स्ट कैन यू आइडेंटिफाई सच एम्बेडिंग की जिसमें दो एजेस एक दूसरे के ऊपर इंटरसेक्ट ना हो रही हो. इफ यू कैन, then that graph will be known as a Euler. That graph will be known as a planar graph, sorry. Otherwise not. Okay, so first question, say first, second, third mostly will be focused on the planar graph only. Second question, check whether the following graphs are planar or not. Once again, the similar kind of question, but now instead of providing that particular graph, I'm using some of the common notation that first of all you need to check whether the Peterson graph is a planar or not. Now you guys are aware about Peterson graph, that particular star graph with connection of pentagon, is it? That particular Peterson graph, you need to check whether that is a planar or not. Similarly, you will go for the complete graph K3 and K7. Complete graph K3, the K3 will be 2 regular graph, K7 will be 6 regular graph. You will be checking whether that graphs are planar or not. Then after complete bipartite graph, in the section of complete bipartite graph, you are supposed to go for K4, 3 and K7, 1. Now it's very, very easy when you are checking K7, 1. Surely it will act as a planar graph. K7, 1 planar graph. Hey, kyun? Because in one of the partition we will be having a single vertex, in another partition it will be 7 vertices. Then surely we will have 8 number of region. Out of that 8 region, 7 will be interior region and one of the region will act as exterior region, is it? So surely K7, 1 will act as a planar graph, but you need to check for all of them, complete graph K3, then after complete graph K7, then after complete bipartite graph K4, 3 and K7, 1, is it? And then after question number 3 says that embedding the following graphs in planar graph, you're just supposed to identify one of the embedding which represents, which can prove that these graphs are planar graphs. So try to identify such embedding in third question. Then in the fourth question, Kutosui's second graph is planar. Is Kutosui's second graph is planar? Why? Is it? Oh, not why, sorry, verified. Okay, 2 graphs are there whom we had labeled as a Kutosui's graph, is it? याद है किसी को Kutosui's graph कौन से है दो?
Sir, K5 and complete bipartite graph 3,3.
Complete bipartite graph 3,3 and complete graph K5, is it? Both these are known as a Kutosui's graph, is it? And both that graphs are non-planar actually, is it? With some of the characteristics such a way that K5 is a non-planar with minimum number of vertices in the complete graph section, and K3, 3 is a non-planar graph with minimum number of edges in complete bipartite graph section, is it? So yes, ये दोनों bipartite, ये दोनों graph planar नहीं है. बस ये आपको verify करना है. क्यों नहीं है? क्योंकि उसकी कोई ऐसे embedding आप identify नहीं कर पा रहे हो, is it? So that is about question number 4. Then if you focus about question number 5, derive Euler's formula. Euler's formula that, याद है किसी को Euler's formula? N plus E minus V equals to 2. याद है, when we are dealing with number of vertices, number of edges, number of faces, and addition and subtraction of that is equals to 2. I had already shared. उसके लिए तो you may use my PPT, is it? I had provided that solution. Then in the sixth question, in the question number 6, so that the graph is planar by drawing it in one plan without any edge crossing, verify Euler formula. Okay, check करना है कि ये planar graph होगा. I know that this graph is planar. You just need to verify the Euler's formula for that particular graph. Okay, Euler's formula उसके लिए verify करना है कि whether that addition and subtraction leads to 2 or not. So that is about question number 6. And similarly, verify the Euler's formula in the question number 7. I had provided some of the graph in question 7, that here is a 3 graph, is it? You can easily identify all that graphs are planar graph. In the second graph, if you represent that connection between B and D outside, then surely it will gonna act as a planar graph. Here, if you can think for the first graph, then yes, none of the edges are intersecting each other. Once verify whether this particular graph is planar or not. Again, if this graph is going to act as a planar graph, then surely you need to then if that graphs are planar, then you need to verify the Euler's formula that. But if that graph is not planar, Euler's formula is not true. If we cannot even talk about Euler's formula if a graph is non-planar, is it? So अगर वो ग्राफ प्लानर ग्राफ है, then you will try to verify the Euler's formula. अगर नहीं है, then it's okay. We don't need to go for the Euler's formula, is it? And similarly, same portion is there in the question number 8. You will be going to verify Euler's formula for some of the well-known graph like Peterson complete graph K3, 5. Then after some of the complete graphs, is it? And question number 9, it says about that. If G is a connected graph, connected simple graph with E number of edges and V number of vertices, where V is greater than equals to 3, then show that E will be less or equals 3V minus 6. E is number of edges, then number of edges must be less than or equals to 3 times V minus 6. Now, here in question number 9 and 10, you need to use your common sense. Okay, first of all, you will try for question number 9 and 10. If you're not good, if you're not comfortable, then I will help for 9 as well as 10. Okay, but for first 1 to 8, it is quite simple kind of stuff for you guys. So what you will do, be ready with your assignment book. Be ready with your assignment book. Start your work from question number 1. Move up to question number 8. Once you are done with up to question number 8, then let me know. We will solve question 9 as well as 10. Okay, do we have any query related to this? Let me know if there is any query, any kind of issue, any kind of question, then let me know. Or if you're not having any kind of query, then drop a message on the chat box right now. I'm good, I'm clear. You need to acknowledge.
Excuse me, sir.
Who's that? Yes, Mohammed, please go ahead.
Sir, can you just like a kind of revision for the Kurotoski's graph, sir?
Kind of revision for the Kurotoski's graph.
Yes, I know of K5 and complete bipartite 3,3, but can you like explain it once again, sir?
Okay, be with me. Be ready with your pen and paper. Just draw the K4 complete graph with 4 vertices, which will act as a 3 regular graph. And you can easily identify that K4 is a planar graph, is it? Then try to draw K3. It will act as a planar graph. Surely it will be acting as a planar graph. K2 itself a planar graph, is it? But when you try to draw K5, complete graph with 5 vertices, that graph will be 4 regular graph. You will not able to identify that embedding. You will not able to identify the embedding for K5. उसमें 2 वर्टेक्स ऐसी बाकी रह जाएगी कि जो एक दूसरे ऊपर इंटरसेक्ट करेगी, मोहम्मद, is it? So K5 is the first graph in the complete graph section. Complete graph जो है ना हमारे पास K2, K3, K4, K5, K6, K7, K8, all that. उसमें से सबसे पहला ग्राफ है K5 कि जो नॉन प्लानर है. Yes, जो कि नॉन प्लानर है. So this is the specialization. This is one of the characteristic कि जिसकी वजह से वो थोड़ा अलग है और उसको हमने एक नया नाम दिया है, नया लेबल दिया हुआ है, that is Kurotoski's graph. Is it? So that is Kurotoski's first graph. उसकी speciality क्या है मोहम्मद? That is a first complete graph which is non-planar.
Yes, in that case.
Or in other words, in the section of complete graph, this is a graph with the minimum number of edges whose non-planar, is it? And if you talk about the second one, that is K3, 3, complete bipartite graph. Now, the similar logic is that in the complete bipartite graph section, when we talk about K2, 2, then after K3, 1, then after K2, 3, all that are surely going to act as a planar graph. But when we talk about K3, complete bipartite graph, where both the partitions are having 3 vertices, and every vertex of single partition will have the connection with each and every vertex of the second partition, is it? So when you try to draw K3, you will not able to get the embedding for that. Surely more than 2 edges will intersect each other, is it? So surely we may conclude that this is a non-planar graph. Now, this is the non-planar graph with the characteristic that it has a minimum number of edges. It has a minimum number of edges, is it? We all know that K3, 3 will have 3 into 3, 9 number of edges with it, is it? So this is the graph which is non-planar in the section of complete bipartite graph with minimum number of edges. So this is the reason both these graphs are known having a kind of different label, is it? One of them, K5, is having a label Kurzweil's first graph. Second is having the label Kurzweil's second graph. One of them belongs to complete graph section. Second belongs to the complete bipartite graph section. Am I clear, Mohammed?
Yes, sir.
याद आ गया, समझ में आ गया?
हाँ, sir.
Good. So all of you are requested to start. ये assignment 6 start कर दो चलो. I'm just here. I'm muting myself because मेरी तरफ से कोई आपको disturbance ना आए. That is just the reason. If you need any kind of help, then just unmute yourself. तुरंत बुलाना मुझे, मैं यहीं पे हूँ, तुरंत ही आ जाऊंगा. ठीक है? Start your work. चलो. Hopefully, all of you are doing your work. Is it? Yes or no? काम कर रहे हो ना? मानसी, देवांश, Just, Priti, Nikita, Smith, Manav. Reply on the chat box right now. Good, good, good. Continue, continue.